In Program 4 for Unit 6, we'll be using the Consumer Price Index data that we compiled and stored in the Learn Something New section of the unit. Here in these lines we open the shelf object and retrieve the data in the usual way. The only confusing thing here is that we've used CPI 1, 2, 3 times, each time with a different meaning. Let's see what the different meanings are. First, the shelf object is stored in a file outside the program. Here's my directory, and here are the files called CPI. So when we call shelf.open, we need to pass in the name of the file so that a connection can be made. This CPI is the name of the file. A shelf object is something like a dictionary. So to retrieve data from it, we need to use a key. Our data is stored using the key CPI, and that's the meaning of this CPI here. Finally, the value associated with this key is itself a dictionary, the dictionary containing all of our index data. We can use any name we like for this dictionary. We don't need to use the same name we used when we created it. But we might as well, since it contains the Consumer Price Index data. In fact, in this case, we do use the same name, CPI, for the dictionary which was stored inside the shelf object. Next, for this problem, we'll be needing a function that computes percent increases. Let's write a function that takes in a beginning number and an ending number and tells us by what percent we increase when we go from the first one to the second. The formula is given in the problem statement. It looks like this. Let's test to make sure that this functions correctly by giving it a problem with numbers where we know the answer. When we increase from 50 to 55, we are going up 10% since the increase, 5, is 10% of 50. Let's run this and make sure we get 10% as our answer. We don't, and looking back at the formula, we can see that we made a small error. We try again, and now we get a correct answer. Now we can write the main part of our program. We'd like to go one by one through the years. I'm writing this in the spring of 2009, so summer 2009 has not yet occurred. Right now we can go through all the years from 1913 up to but not including 2009. For each one, let's calculate the increase in prices over the summer months. We use our percent increase function and pass in the index at the beginning of the summer, that is in May, and the index at the end of the summer, that is in September. What we'd like to do is find the largest increase. Let's store it in a variable called max increase. If the current increase is larger than the largest one we've seen so far, then we'll save it. Also, let's remember the year in which it occurred. When we've been through all the years, all we need to do is print the year in which we saw the largest increase and the increase that we saw in that year. Here's our program. Let's test it out. The largest increase was in 1946, just after World War II.